You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host. I'm back here again with Al Dumdei. How are you doing today, Al?
Hey, good, Dan. You're someplace different again today. It's like you're like, where in the world is Dan Klamert today?
I'm in the witness protection program. Yes, trying to. I'm on the run. Life on the road.
Must be.
Yeah, I'm outside today. Actually, it's beautiful out here.
It
So
is.
hopefully,
Looks nice.
Looks lovely weather.
Yeah. So this week on episode 66, we've got a great episode here planned. Very exciting. We're going to be talking and giving a 802.11 update. And I would like to welcome to the show some special guests here. Welcome, Brian Hart. How are you doing today, Brian?
Hey, g'day. Good to see you.
Thanks for your time today. And also Binita Gupta. How are you doing today, Binita?
Yeah, I'm doing great. Yeah, pleasure to be here, Dan and Al.
Thanks so much for joining us. And also we have Juan Carlos Zuniga. How are you doing, Juan?
I'm doing fine, thanks, and glad to be here with you guys.
Hey, so Dan, it's
Super
not
excited
uncommon
to
that
have
we
you.
have heavy hitters on the show, but we don't always get celebrities, right? So yeah, these guys are actually
authors, right? Authors
of a Wi-Fi 7, trying to get the Centered Up a Wi-Fi 7 book, right? So
Yes.
and there's not many of these out in the industry yet. So these are, like I said, we have real live celebrities today, right? So,
Yes.
and
Yeah,
by the
that's what I
way, if
said.
you don't have your copy of the book, you can pick it up, right? So
Where can
we'll
we get
probably
it? Where
cover
can we
that just
get
a
the
little bit
book?
at the end also, but
Oh, okay. All right.
it is a really good book. I do use it all the time. So secret weapon.
Yeah, it's great. No, I'm glad. Yeah, thank you. Like I said, super excited. So just real quick before we get rolling here, this is being recorded to YouTube like usual, and that's on our channel at youtube.com/@getunplugged. And I would encourage you, please, to go out there and subscribe, click the notification bell. You'll be notified when we do go live with more great content like this episode. So just wanted to get that reminder in there. And do we want to, Al, do we want to talk a little bit, have our guests introduce themselves here?
Yeah, let's do that. Let's, because again, not typical kind of folks that we have, right? So maybe Brian, you want to just start with kind of your background and then maybe Benita and then JC?
Yeah, thanks, Al. I've been working in Wi-Fi for, getting on for 25 years now. I started doing chipset development, baseband signal processing for our original 11 ABG chips, which went into the 1131s and 1142s back in the day. And since then, I've, just continued doing a whole bunch of Wi-Fi location type stuff at Cisco, currently in the wireless architecture team, which is part of the Wi-Fi product team. And I'm working with these very...
The mood rings? Were they the ones with the mood ring?
Yeah, that's right. The mood ring. That's right.
One of my favorites.
Yep. Benita.
Yeah,
Thanks,
hi.
Brad.
Yeah. First of all, great to be here and, with Brian and JC and Al, Dan. So my background, I think started in Wi-Fi 7, been, heavily engaged there, contributing to several features, and we will talk more about that. And now we have next generation of Wi-Fi 8. And then I do have a wireless background, 20 plus years. Different companies. Have been at Cisco for now 2 years in the Cisco wireless engineering team. So glad to be here. And we're working on Wi-Fi 7 and Wi-Fi 8 products.
Benita she's not real tall, but let me tell you, when she gets up in front of these standards committees, she casts a long shadow.
It's hard to tell. We're all the same height on
Kind of like E.F. Hutton
on the video too. Very true.
Yeah.
Thank you.
Welcome. Thanks.
JC.
Yes, hi everyone. So Juan Carlos Zuniga here, and also I guess we are old-timers in the standards in general. So similar to Brian and Binita, I've been for over 20 years doing different type of standardization, starting from the .16 days and WiMAX, what became WiMAX, moving on to Wi-Fi mesh back in the day. Then life took me to do more cellular generational 3, 4, 5Gs, and IoT in different companies and countries. But now I'm glad to be here at Cisco working with people like Binita, Brian, and Al on the standardization. So my role is mainly to help with the coordination, the standard strategy. I'm in the global technical standards team, a part of the strategy office of Cisco, also representing Cisco at the board of the Wi-Fi Alliance, and so happy to be here with you guys to talk about all the exciting things that we're doing in this last Wi-Fi 8 generation of connectivity.
Awesome. Yeah. I mean, you do things like IETF, like you said, Wi-Fi Alliance. I mean, you really cover the gamut in standards from a Cisco standpoint, don't you?
Yeah, exactly. I've been always flying between layer 2 and 3, depending on whether I get a promotion or a demotion. Yeah. But yeah, that's been indeed my work in both organizations. Sometimes working as a liaison. The fact that I can speak both languages is really helpful sometimes to
Sure.
translate and make sure that we can help the industry, the ecosystem move ahead.
So, question, somebody who's not part of the standards, I'm kind of listening to this for the first time. Why should I be interested in standards? I mean, it sounds boring, right? I've since learned it's not. Maybe we get a chance at the end. We got a few stories. I haven't been at it that long, but I have a fun story from the last session. So, but I mean, why would I care, about 802.11 and that sort of stuff if I'm just, all I'm really doing is deploying Wi-Fi.
Yeah. So I'm definitely, it's standards is a mixture of technology and politics, and both can be quite exciting. But really, the reason we attend, the reason Cisco, helps us attend is really about the customer, solving customer problems. When we think about it, 802.11 didn't really come about by magic. It has been a 20-odd year evolution. And each time you've got a whole bunch of people saying, hey, I think I see a problem, I want to fix it. And when they fix it and the problems that they try to solve, our job is to go in there and help people understand enterprise problems and what an enterprise solution looks like. And I say that because some people, totally legitimately based on the customers they're familiar with, will be quite happy with, a couple of clients talking happily to a home AP and draw a big tick under it. Our goal is to make people realize, actually, no, we deal with hundreds and thousands of APs and thousands and tens of thousands of clients all on the same site. And, we have some pretty rigorous security requirements and usability requirements, reliability requirements. And so, our role is to engage and help, those quality of service security goals.
I think also something important that is that for people that have never heard a board standard, or maybe they've heard it from the distances, on top of what Brian is saying is standards allow interoperability between different vendors in different regulatory domains. And to me, Wi-Fi is one of the pristine examples. I mean, the fact that you had to change your plug to recharge your phone in Europe or the US or Asia, that just shows you that there's 3 different standards, whereas Wi-Fi is the prime example that you can still bring your Wi-Fi device all over in the world, and then people just say, do you have Wi-Fi? And they just take it for granted that it'll work. And that is precisely the end result of the work that 802.11 has been doing for many years. And to me, is one of the great success stories. Of course, the internet, IP, and so on are the back all of what's happening. But this time, most young generations take Wi-Fi and internet interchangeably, because for them they just take it for granted. It'll work, and that's part of the magic of the standard.
Yeah, that's a great point, JC. My son, who's going away to college here this last weekend, he comes, Dad, I need to talk to you about something. I'm like, okay, what's going on? Well, I apparently we need to call he's moving into a house off campus, and apparently we need to call a technician to get Wi-Fi in the house. Like, I thought it just came with the house. Like, I mean, it's really become a utility, right? It's like, okay,
Yeah.
so like I had to talk to him. I was like, what are the providers in that area? Like, you're gonna have to call them, schedule, or go online to schedule it. But he was floored that the house didn't come with Wi-Fi, and he's fairly technical, but he's like, okay, so do I have to put in a router and access points and stuff? He's like, I said, well, they should be able to help you with that, but to your point, it's it's a surprise sometimes to people, but it's an expectation, more importantly, like you said.
So,
Yeah.
yeah, totally. Yeah, just to add on to that, right? I think each of us use Wi-Fi everywhere. We go everywhere. We are working at home, on the go, and us as part of standards, we do a lot of travel. So every
Mhm.
2 months, there's IEEE has their standards meetings where it's a complicated, it's a very involved process to develop the standards, and it's not few companies, it's hundreds of companies coming together, more than 600 members who are actually voting members of IEEE working group. They all meet in person. Obviously there is hybrid now, these meetings, but we travel every 2 months for these IEEE 802.11 meetings to essentially collaborate with industry peers to develop these standards. So it's a very involved standard, and I think the set of features which get developed obviously impact all of us. The performance improvements we see in terms of higher throughput and higher better roaming, or improved latency, that enables the applications which we are using, like video conferencing, like this video streaming or conferencing solutions, right? So I think as an end user, at a very high level, if we know what are the features in every generation of Wi-Fi, that enables us to make a better decision of what suits in different scenarios for our use cases. And then coming to the point which Brian was saying, enterprise has many verticals, right? Where Wi-Fi is ubiquitous, right? Industrial, corporate enterprise, healthcare, logistics, warehouse. So all of these have their own set of problems and challenges and use cases to be addressed. And from Cisco point of view, we want to bring those use cases and problems and challenges to the standards and make sure that it is getting addressed from those verticals point of view, because we want to bring value to the market across all those verticals with every new generation of Wi-Fi standard. So from Cisco point of view, it's really, really important for us to drive the standard and make sure those solutions are bringing value to different enterprise verticals.
I have a question. Sorry, Al. Is that okay
Go
if I
ahead.
jump in here?
Yeah, go ahead.
Being that you've been on these standards boards and discussions, or for several years, and this is for anyone really, but it seems to me like, as someone in the industry, but not necessarily directly on these boards, is that the timelines have accelerated quickly over the years. It seems like standards development has rapidly picked up, and we're getting new standards at a quicker clip. Is that true? Is that something that you've seen over the years? And
I want to say yes and no.
Okay.
I mean, I'd say in the earlier days of .11, you'd get a major generation about every 5 years.
Sure.
4.5, 5,
Yep.
and we typically have like a mid-session upgrade. Say 11 Wi-Fi 5, 11AC. We had a
Sure.
release 2 with quite major upgrades. What
Sure.
happens recently is people have accelerated that to a 4-year cadence.
Okay.
But also there was this extra wild card where we got this amazing new capability, which is that 6 gigahertz spectrum, which is
Yes.
just this huge, fast, wide open new lane for us all. And so that
Yes.
created kind of a disturbance in the force. And we got this, essentially Wi-Fi 6E was this extra thing thrown in on top of that 4-year cadence. And so
Sure.
that was sort of probably once in a decade kind of an experience. And,
Sure.
we couldn't wait for that. And so that instead of one every 4 years, it seemed a bit faster than that. Yeah.
Okay. That's
Yeah.
fair.
I was just going to add, I think because I've kind of seen these guys in action. And when you go to an IEEE conference, there's a lot of very passionate engineers that have ideas. Not all of them are good. right? And so that's one of the reasons why I think these guys are so important to Cisco, right? And to the industry in general is that they're kind of like the centurions, right? That not only are they bringing proposals and that sort of stuff, they're also sort of preventing bad things from getting in there, right? So they have to do kind of both aspects of that. And there can be a lot of shenanigans that go along with the politics of that, but if we have time, we'll talk about that later.
Yeah.
So good.
Yeah, totally. Yeah, adding to that, and what Dan was saying, right? It's there is a timeline, right, for developing every standard. So I think one of the job which Al you're saying is to make sure the important problems and use cases are addressed versus so many members bringing in different solutions which may solve a fringe problem, but that's really not where the focus should be. So yeah, and I think
we talk about
do that.
solving.
Yeah. Mm-hmm.
Sorry, Binita. Yeah, absolutely. And we talk about solving important problems, corner cases of corner cases. Some people come in with solutions to corner cases of corner cases of corner cases, and they go, I accept your problem, but it's just not a great use of our time.
We're inventing the problem so we can come up with a solution. So let's we've kind of talked about it. Let's go through the IEEE. Tell us, where are we at in these processes? Tell us about the standards. What if I say IEEE 802.11? What does that mean, right? What is it? Tell me about it, right?
Sure. And so we have one major standard. There's some early other stuff that we can basically ignore. Essentially, there's one standard, which is 802.11. And there's actually a lot of analogies between the 802.11 standards development and also software development. In software development, you've got a repository, you've got major releases, you've got branches, and then merge activity. And that's really what's happening in this .11 context that we can see here. We have, the last major release was 802.11-2024. So that's how we identify it. There's some very mature branches, and I'll point out 11BE, which we know is really Wi-Fi 7. And these have since been merged in to the baseline, and the new head of tree is this RevMF maintenance revision. And then there's some other branches that are somewhat less mature. Now, another way to think about this is really, given a particular branch or a particular project, how does that come into being? We might start with some initial discussion. There's this wireless next generation forum, which allows people to present. If people say, yeah, I accept your problem, I see, it's not just a corner case of a corner case, and it is feasible to solve, then people say, hey, let's move forward. And so maybe it starts as a topic interest group, like automotive, coverage across a whole city. That's an interesting problem. Post-quantum, which we'll talk more about. Those are in their early days. And essentially, the study group creates the scope of a task group. And a task group is really where the real work happens. First we prepare a draft, then we review that draft very diligently. Hundreds of people, line by line. Thousands of comments on minor and major issues, emissions, what have you. Typically would have 3, 4, 5 new drafts, progressively fixing all those issues. When it gets to a certain level of maturity, the working group says, we're good with this. Let's open up to an even wider community. So the entire IEEE Standards Association is then able to comment on it. And for wireless with a shared medium, like say Bluetooth and Wi-Fi and everything else, that's particularly important. So those comments come in. The working group, really the task group related, continues to work on that and fix the problems. And at some point, people say we're done, and that's the published amendment. When essentially, 99% of people are happy. And then, in fullness of time, it gets rolled into the next major release. So that's sort of the framework of how these things are developed. And JC, do you want to take us through some of the Mac level features?
Yeah, sure. Thanks, Brian. Well, let me start, let's say, from after Brian just mentioned the different verticals. If we look horizontally, there's also like a timeline of how a project gets more mature as it advances in the specification. As Brian mentioned, most of these specifications are amendments that will be merged onto the baseline. but during their timeline as a study group, task group, and then moved on to a proposed amendment, they are taken separately. So in this case, for instance, if we take a look at security and privacy, that's a big topic that is coming up, and as you guys know, people are getting more and more aware of the issues that come with internet connectivity, having online content, and all this type of things. It's a work that we have to take in advance, because the time for us to produce the standard and have it into the market is it's a time game. So we really need to see what the problems will be in the next few years and start tackling them right now. So in the case of privacy and security, the group started with BH, that it's now already finished and published, because it was identified as an issue about privacy. Wi-Fi was being misused basically by bad actors to track users without their consent. So that took us to look into the specification and see that we were actually broadcasting some identifiers that were being used to track users without their knowledge. So that was not a good thing. BH came in, and then AQ and other specifications that allowed getting rid of those identifiers. That was a very, very good step. And then BI moved on to say, well, we need to take this further, because not only there is an issue with the specification, but also the attackers are getting more and more sophisticated. And of course, as you know now with AI and all these things, it's very easy to get complex code and do smarter things. So we realized that there were other means to identify the user by correlating different parameters and getting a little more sophisticated. So BI is precisely looking at that part of the privacy. And then just to make sure that people understand, privacy and security overlap a little, but privacy is really about the user, like making sure that we keep the user safe, where security can encompass the data and the device itself and other things, the infrastructure, for instance. So not necessarily user related. Of course, there's a big user component, but that's the slight difference between the two terms. So along those lines, the last group that we've been working on that Cisco cares very much about is PQC, or post-quantum cryptography. And this is the new group that came up because we know that in the near future, we will have quantum computers that will be able to decode or decrypt basically the current encryption algorithms that we are using these days. And because we can keep data in storage, that data can be decrypted in the future. So it's a really interesting time game here. But what we need to make sure is that we protect today the data for the future computer, if you understand. So what we are doing now with this post-quantum crypto group that is just being formed is to see what needs to be changed in the specification to make sure that in the future quantum computers will not be able to hack basically the connections that we are doing these days. So that's pretty much what is going on the security, and there's other advances on Mac and Phi, but Brian, Benita, I don't know if you want to talk about the rest.
Yeah, I can. Yeah, thank you, JC. Yeah, so I can add, obviously we had Wi-Fi 7 being, the last amendment which is released. So, Brian and myself, we've been heavily involved in, driving many features there, several contributions. So I can give a, flavor of how Wi-Fi 7 or 11BE evolved, right? EHT, it's called extremely high throughput. So every generation is trying to, better the previous generation, right? That's really the goal here. So with the EHT, extremely high throughput, we call it 11BE, or, Wi-Fi 7 is the Wi-Fi Alliance name for it. And we'll talk more about Wi-Fi Alliance in a bit. But essentially, the 11BE is bringing in, much higher throughput. That's suggested in the name, extremely high throughput. Improving, throughput is one of the main goal. At the same time, at the time or during the period when the EHT or BE was developed, there were several new applications coming into the market. Obviously, video conferencing, more prevalence of video conferencing, work from home due to COVID situation, as well as this AR and VR applications, becoming more common in several verticals. And those required, support for lower latency over Wi-Fi, as well as better predictable latency and, high reliability. So one of the other goal of EHT, or, with the features it introduces, is essentially to provide more predictable low latency and higher reliability with achieving more deterministic performance for applications over Wi-Fi. So a couple of really fundamental architecture features in EHT have been a multi-link operation, MLO feature, that essentially change how the stations and the AP now interact with each other. Earlier, it used to be on one link, one band. With MLO, essentially stations and access point now can set up multiple links on multiple bands, and then based on the capability of station, it can essentially have data transmission and reception over multiple links at the same time. Or if a station does not have the hardware capability, it can use any one of those links at any given time, and that gives a link diversity. Whichever link is available and clean, it can essentially dynamically switch to making use of that link. So MLO brought, latency gain and reliability gain with the link diversity, as well as the higher throughput with, link aggregation across multiple links. And then there were a number of other QoS enhancements added, and we can go into detail if needed, but essentially it enabled more predictable latency with this stream classification service, where stations can provide its own traffic requirements to the access point, and then access points can essentially schedule channel access for those stations meeting those requirements. So that was a fundamental improvement and optimization added in EHT, enabling these newer applications like AR, VR, industrial automation related, robotics related applications as well, which are more critical for low latency.
And if you want a deep dive, Binita wrote some fabulous chapters in the Wi-Fi in Depth book.
On MLO, yes, and back layer features, and Brian, too. There are. And you want to cover PHY enhancements because there are.
Actually, I will just do it briefly, in the sense that one big new feature in EHT was defining 320 megahertz, and that's only available at 6 gigahertz, which is a great way to get more adoption of 6 gigahertz, which is this wide open lane for great quality of service. Now, it happened that there was also earlier work on Wi-Fi location, which predated EHT. So in order to add location ranging for 320 megahertz, which gives us better accuracy, there was another amendment, 11BK, for positioning. Also, there's work completed now on sensing, for instance, elderly fall detection. If they fall and are not moving, that can be 11BF sensing enables the detection of that, and that, which can then trigger remediation. We're going to talk more about UHR. Other things that are early on that we'll just quickly go over: ambient power. These are sort of devices with very low power, just maybe being energized by an AP in order to transmit a few bits of status. Integrated millimeter wave. This is essentially, looking at 60 gigahertz with a fresh eye and trying to make a very implementable flavor of millimeter wave. And even beyond millimeter wave is light communications. And as Binita was saying, EHT introduced this new technology, multi-link operation. But again, the earlier work on light predated EHT. So in order to add MLO, to make light available as an MLO technology, we're going to have a new amendment, this 11BR ELC amendment. So that's keeping the whole team busy. As we said, there's hundreds of people attending 802.11. We're all part of the same working group. So our remit is to review and improve all of these. But typically you find people specialize a little bit. So there's a large contingent, the sort of classic MAC-PHY connectivity amendments generations like UHR, and then there's more specialized teams working in, say, AMP and Lightwave.
So quick, if someone were to say, I understand Wi-Fi 8's coming out in the future. Where's Wi-Fi 8 in here?
Yeah, Wi-Fi. Well, first of all, Wi-Fi 8 is 11BN UHR, and we can see it's
Yeah.
got many hurdles to go through in IEEE, and we're going to come to Wi-Fi Alliance as well, where it's in its early days. Just actually within the last few days, draft 1.0 got prepared, and generally draft 1.0, it gives you a sense of what the standard will be, and people can start implementing to that, but it's certainly not mature enough for interoperability. There's a bunch of open questions that will continue to be refined in the next couple of years. And yeah, Wi-Fi 8 is really still years away.
I have a question, a follow-up here, I guess, to Brian, Benita. You've mentioned the Wi-Fi Alliance here, and
Yeah.
just for our viewers, we've talked about some of this stuff in the past, but we're talking about the IEEE here. We've mentioned the Wi-Fi Alliance. How do these organizations, what are the differences, I guess? Do they work together? And I don't want
That's
to
a perfect
steal your
lead-in.
thunder here in the transition here,
so
maybe.
true.
But,
yeah.
Next slide.
But, is there an order of operations there in that process too?
Yeah. It's a dance. Essentially, you have two organizations that are ships in the night, but they also work very closely in tandem. And
Sure.
a hell of a lot of people who work at 802.11 are also working at Wi-Fi Alliance and trying to create a pipeline of activity. And so, just to sort of, expand on that. So the Wi-Fi Alliance, we can think of it as having kind of three waves, so-called marketing task groups, technical task groups, and then established certifications. And so when you get a certain level of maturity in a task group, maybe before draft 1.0, if it's a really obvious thing like Wi-Fi 8, maybe later if it's a newer technology. But at some point, people will take that IEEE work to Wi-Fi Alliance, and in the long range task group say, hey, there's this stuff happening at IEEE, it's important, the industry expects to use this, we should have some interoperability certification for that. Because Wi-Fi Alliance, at a very high level, IEEE is creates the buffet of a whole different set of features, either different amendments or different features within those amendments. And the Wi-Fi Alliance puts on their marketing hat and says, does the industry really care about that feature? Is it solving something that's important? And will people be building products to meet that? And then based on that marketing expertise, certain things will push forward. And so, 11BN, it's going to happen. And so, you then pivot from the long range task group to create a marketing task group that starts with a statement of work, what they're going to do. But their real main deliverable is the so-called market requirements document, which sets out what use cases we're trying to solve. And a key part of that section is which features need to be mandatory on the AP and the client, and which ones will be optional. And then later, for us many years later, for Wi-Fi 8, they may generate some marketing documents that are published externally with staff, a lot of staff assistance.
If I may add a little bit here, just anecdotal. I think it's interesting that Wi-Fi Alliance is the one that came up with the Wi-Fi brand. Basically, they own the trademark. And after going and debating over multiple weird names like Hornet, stuff like that, someone said hey, everybody talks about hi-fi back in the day, right? So why not make it wireless? And even though in the beginning they were trying to be called a wireless Ethernet alliance because it was they want to be, they actually became a thing on their own. And as we know, again, they are super successful, and both Wi-Fi name and logo belong to the Wi-Fi Alliance. But as Brian is saying, they're the ones that take the complicated specifications into the market and try to make sure that that's what the actual products certify against. So the generational thing, that's actually Wi-Fi Alliance, who will say this is Wi-Fi 6, and it's comprised of this subset of features, Wi-Fi 7, and in this case, Wi-Fi 8, which mainly will be BN, but also chances are some other amendments will make it into it.
So yeah, totally. I think to add a little bit more to that, in the journey of Wi-Fi 7, so 11BE amendment from IEEE essentially was taken as input for Wi-Fi 7 certification program in Wi-Fi Alliance. and that you see on the Wi-Fi 7 here, right, as one of the certification. So in the journey, right, I think as Brian was saying, the Wi-Fi Alliance will take, say, 1.0, draft 1.0, or I think communication start when draft 1.0 is either published or close to publication, and because then the members who are participating at IEEE and also similar members in Wi-Fi Alliance have a good idea of what features are in. Although there is a lot more work to be done still. But the conversation in the marketing task group in terms of use cases and defining what features go in as mandatory versus optional starts close to that. And then we essentially move to developing what's called test plan here. Wi-Fi, that happens in the technical task group. And test plan is where the Wi-Fi Alliance develops this interoperability testing for every feature which needs to be tested for that particular generation. Essentially, there is a very detailed test plan written going into the level of bits and bytes over the air protocol testing. So the goal is really to make sure the devices, the stations, and the access points are interoperating with each other from different vendors. So it has to be it has to go into very detailed testing in those test plan, and essentially those testing is completed over a series of plug fests, and several companies participate in those, and these plug fests are typically 2 weeks long or it can extend beyond that as well. And
Which tells you how complicated these things are. And in the beginning, it was 1 week, and then a few generations, 2 weeks was unavoidable. And nowadays, it's more like 3 weeks, as you say.
Yeah. There's the virtual, yeah. There is also, the in-person plug fest happening, and then if more testing is needed, there are more weeks added, which are, virtual. But so things may not need to be there in person in the labs, but yes, it extends to outside those 2 weeks. Yeah, because more and more features are added, and then I think testing of those features from interop point of view is extremely important before these get shipped as part of the certification. So yeah, I think these are becoming more and more stretched.
Absolutely.
Yeah.
And at the end of the day, something like Wi-Fi 7, there's a launch, like a publicity thing, but behind the scenes, more importantly, test houses are able to certify devices for interoperability against that test plan. And then the test plan becomes essentially one of the many available certifications from the Wi-Fi Alliance. We've listed a whole bunch here, which are more relevant to the enterprise. Obviously, the connectivity generations, for Wi-Fi 4, 5, 6, 6E, which is really just Wi-Fi 6, but it was a major upgrade, and Wi-Fi 7, Halo, which is sub 1 gigahertz, and WiGig, which is 60 gigahertz. These have had less adoption than classic Wi-Fi. Security is obviously incredibly vital. WPA3, protected management frames, enhanced open. These are certifications that help protect our data. Passpoint for easy connectivity, agile, multi-band, and optimized connectivity provide for greater quality of service, particularly in a multi-band world. And then there's other, more specific certifications like for screencasting, mirrorcast, and also for ranging, like Wi-Fi location. And then a whole bunch of quality of service related certifications, including WMM, way back in the day. Now, just to put the earlier context, quick question here: where is Wi-Fi 8 at? And Wi-Fi 8 has completed a statement of work, and we're just starting to discuss use cases. So there's a very long journey. We don't know which features are mandatory or optional. Obviously, there's a whole bunch of jockeying behind the scenes. People have their favorite features because it really helps their market. But is that enough for the whole industry for it to become mandatory, or might it stay as optional? All those discussions are open. There's been no interoperability testing, nor even sort of discussion of what kind of tests are needed to validate each of those features.
And I think Wi-Fi 8 has a long journey ahead, right? Yeah. I think one item I wanted to highlight here on the Wi-Fi Alliance side of story is most of these certifications are focused on, at least the main Wi-Fi generation are focused on interoperability testing. There are obviously, some, like we're talking about improvement in latency, better reliability, right? In terms of the resources, these Wi-Fi, mainstream Wi-Fi generations do not get into the performance testing in terms of latency and reliability. So there is dedicated cause management, which you see on the right side here, cause management certification that essentially takes over some of these performance testing for quality of service features. So, testing for lower latency, better reliability, and it has essentially taken the features from Wi-Fi 7 and previous releases and doing the performance aspects, for those. So, including, I think I mentioned stream classification service. And then some AP side policy, DSCP policy, testing for achieving better uplink QoS in certain verticals, and then latest in the release 4 of QoS management, there is dynamic analytics reporting on QoS performance from both AP and the station side. So there is this performance aspects also getting tested in Wi-Fi Alliance, although not in the mainstream, but in other certifications of cause management specifically.
Yeah.
So it
Yeah,
seems
that's
like we're
important. Thanks.
turning the corner a little bit from speeds and feeds to reliability from a Wi-Fi standpoint. Is that a fair assessment?
Yeah, yeah, and I think we regard that as a good thing.
Mhm.
And obviously, it's kind of the marriage of two things. One, from a sort of technology perspective, it's very hard to eke out extra speed increases without using, say, like almost the whole 6 GHz band. And on the other hand, we're at multi-gigabit data rates already, which is addressing a lot of use cases. So the raw speed isn't really what people worry about. People are, to your point, people are really worried about reliability and
Yeah.
second order things like that. Usability, quality of service, determinism.
So Wi-Fi, what can you tell us a little bit about some of the, like, what's the new stuff? Can you
Yeah,
give-
yeah. Well, gosh,
Okay, good.
we have a slide prepared.
Okay,
Wow.
cool.
And as I said, draft 1.0 was published in the last few days, and so we have a better sense. It's still a work in progress. We don't know what will be part of the certification. If I've learned anything in this industry, is that some of these features won't ultimately make it over the finish line. But I think we have enough clarity that we can sort of put a strong, a reasonably confident estimate of what people should expect to see down the road in several years' time. And we, there's a whole bunch of features. Essentially, people have said, okay, we don't have to increase the speed because, as I just discussed, let's look at all the other problems that have come up and let's see if we can work on them. And so, there are a whole bunch. I want to count maybe 18 major features, but let's sort of prioritize the ones that are more obviously important to the enterprise. Seamless roaming. When you go AP to AP, maybe you're sort of rushing from the car to an office, and you're on the call, but every time you pass by an AP, you don't want to have a dropout. So seamless roaming is a market improvement. Actually, Binita's the expert here, but we'll probably pivot to her. So I'll shut up about that for now. But seamless roaming is a way to improve that. As well, to date, all our APs, even though they're part of the same network, they behave more like ships in the night. They're independently contending and scheduling their data for their clients. But maybe another AP nearby has more important data that's has greater cost requirements or more urgent to deliver that data. And so there's a whole bunch of coordination technologies to help those APs work together more tightly as a team. Some of the features down here help make more efficient use of these 160 and 320 megahertz channel widths. But in the enterprise, we know we often are using 20, 40, 80 megahertz because we're interested in that reliability and stability of the network. But the dynamic bandwidth expansion feature, is a way to essentially very safely operate at wider bandwidth when that's the right thing to do. And then there's other things like periodic AP power save and also dynamic power save for clients, which are great technologies to help reduce some of the power consumption related to Wi-Fi. And then there's a whole bunch of other features. There's some 5 features, such as distributed resource units, which is a technology which will improve uplink ranging, especially at 6 gigahertz. And a new 5 mode, 5 format called enhanced long range that should be, maybe 3 or maybe 6 dB more sensitive than some of the modes we have today, the basic modes we have today. Some new MCSs, so at certain ranges you get a slightly increased throughput, longer LDPC code words, which is slightly, slight improvements, a couple extra, fraction of, in some cases 1, maybe 2 dBs. Unequal MCSs, which is relevant when we start beamforming to clients with multiple antennas, and also interference mitigation pilots that may help us in sort of dense collision type environments. But those are the main 5 features, and then there's a whole bunch more set of Mac features. And Benita, do you want to jump in?
Yeah. If I may add,
let me just one second. Give me 1 second, Benita. I just want to go back because I told you like acronyms. I want to make sure that we're clear.
Yeah.
So the LDPC, just maybe at a 10,000 foot view. What is LDPC? I mean,
it's this great acronym that says low density parity check matrices, which may not leave anyone the wiser, but think of it as basically a flavor of Ford error correcting code that's actually really powerful. And it's really state of the art for most coding applications. And the longer the code word is, the better it performs.
Perfect.
I think on top of excellent description Brian had on these 11BN features, right? I want to highlight that key point, right, Al, which we were saying, right? The focus has shifted to improving the reliability. The standard, itself is called ultra high reliability. That's your UHR. 11BN is called UHR. So really the focus is on improving the reliability, making, different aspects of how, people use Wi-Fi more reliable. So seamless roaming, I think Brian touched on that. Essentially, the goal here is to achieve faster roaming on top of what we have today. It's called FT, fast roaming transition. Faster than that, but also avoid any data loss, right? To minimize data loss as much as, or even go to 0 data loss as a result of roaming. And not require reassociation when you're roaming to a new access point within the same ESS, or what we call now a seamless mobility domain, which is an set of access points which will be defined where clients can seamlessly roam and not have to reestablish keys in certain modes. And essentially being able to retrieve data from the old AP while it is roaming to the new AP and maintain its context as well as it roams. It doesn't need to reestablish context with every new AP it's roaming to. So there is a lot of improvements in seamless roaming to improve the reliability of roaming experience itself from an end user point of view. I think a bunch of new low latency QoS features have been introduced. You can see at the bottom. Starting with L4S improvement, mostly centric on the access point side, where L4S is a technology from IETF, and JC, you've been involved in there, right? So I think it's coming to Wi-Fi now in terms of Wi-Fi access point being able to enable end-to-end L4S over Wi-Fi link, including over the Wi-Fi link, where if there is a congestion on the access point, it will mark the congestion bit for L4S so that the sender can adjust its sending rate to ease the congestion and avoid any congestion-related data loss. And that improves the overall end-to-end latency for these L4S flows. So there is, discussion on supporting that, and it's actually part of draft 1.0 now. There is prioritized EDCA feature, which you see on the right side, which is essentially improving EDCA, which we have today, and giving priority access to certain flows which need a lower latency, and it's not getting access to the medium. So there is certain stations can have a prioritized EDCA kick in when they need lower latency and it is not being met. So again, an attempt to provide more predictable behavior for such low latency application, higher determinism. And then there is another low latency feature, which is called low latency indication, which essentially is enabling a client, if it has an urgent low latency traffic, today client obviously either waits for access point to trigger it to deliver that traffic, or it has to access the channel, acquire the channel. In this case, it can essentially tell the AP, hey, I do have some low latency urgent traffic. Give me some, channel, give me some medium to transfer that. So that's another feature that's getting added into 11BN UHR to address these low latency and improving the reliability aspects. So I'll stop there. I think there are other features. Brian, you want to touch in terms of improving the spectrum, right?
Yeah, actually, just a sort of a worked example why Cisco engages. Say this dynamic subband operation, it's a nice way to AP to schedule clients even outside their normal operating bandwidth. And it's most relevant for 160 and 320 megahertz BSSs. But we know in the enterprise, 160 and 320 megahertz BSSs, we don't operate that way. And so step one is actually the dynamic bandwidth expansion feature, essentially enabling us to use 160, 320, when it's appropriate. And so that's something we champion. Binita and my colleague Malcolm did a great job, devising that feature and making these other features, including non-primary channel access, much more relevant to the enterprise. And that wouldn't have happened without Cisco's participation.
Yeah, great.
And so on top of this dynamic bandwidth expansion, I think this is enabling an enterprise, deployment to kind of target or move the resources where it is needed. So, like an example would be in a carpeted office, right? When a conference or a meeting is happening, all the users are moving to a conference room, and the APs in that room require higher capacity versus APs which are outside in the cubicles, because not many devices are connecting there. So this dynamic bandwidth expansion is addressing that specific enterprise use case where you can move the capacity or the spectrum to the APs which are actually serving higher load. And this is dynamically, at this scale of minutes, 30 minutes, how long meeting is lasting. And so your AP goes from, say, 40 megahertz expanding to 160 megahertz or 320 megahertz for a period of time to serve the higher load, and then goes back to, previous bandwidth of, say, 40 megahertz. So this is enabling those enterprise use cases, and there are applications in education, essentially when the exams are happening, and stadiums, when user devices are moving to specific areas.
Great. So what we need to do is, as these get more firmed up, we'll do another session where we can maybe pick top 5 or 6 and do a deep dive on these features. And also what that'll be a good start to your Wi-Fi 8 book at that point, right?
Yes. Yeah, it was a chunk of work, but very rewarding. So yeah.
So, hey, this has been super informational. I may have to go back and listen to this again just to digest everything. So this is really good. I appreciate you guys doing this. Anything else we want to cover before we wrap up?
Some resources, yeah.
Yes.
So just quickly, we've talked about IEEE, and everything about IEEE is really available from this link, including the document server, which has just got a huge amount of information. If you want to see the drafts, of course, you do have to be a member and join some meetings. And how to do that is available at that link. Again, the Wi-Fi Alliance, to participate, you really have to be a member, but there's a lot of public-facing information. And you can learn about, Wi-Fi certified 7, WPA3, cost management that we've talked about, and so forth. And of course, if you really want to understand Wi-Fi 7 in depth, then the book is really your go-to answer, which is much more readable than the standards. And so we have some information there too.
And I recommend getting both the soft copy and the hard copy, because sometimes it's nice to look things up quickly. Sometimes it's nice to have something to underline.
Yeah.
So, all right. Well, I think that's it for today. Unless anybody's got anything else they'd like to cover, Dan, you want to close it out?
Yeah, I just want to say thank you, Brian, Juan Carlos, and Benita. Great discussion. Thanks, Al. I thought this was super informative. Like you said, I think I'm gonna go back and watch again because there's so much to digest here. But loved it, loved the content, loved the discussion. Thanks so
Yeah.
much for the time. So, as a reminder, here you can check out this and other great content on our YouTube channel at youtube.com/@getunplugged. You can always reach out to us as well if you've got questions, comments, feedback for this episode or others. You can email us at getunplugged@cisco.com. You can send us a message on Twitter X, Unplugged 802.11, or Threads, Unplugged Connectivity. So thank you very much. Appreciate the time. Another great episode. And until next time, stay connected and unplugged.